Multiplying a polynomial by a monomial. Objective of this lesson to multiply a polynomial by a monomial. Okay, recall from our previous lessons what the definition of a polynomial. Polynomial is the sum of monomials, and the definition of a monomial is a number, a variable, or a product of numbers or variables. Okay, so let's take a look at this lesson, how to multiply a polynomial with a monomial. Algebra tiles are named after the area of the rectangle. The area of the rectangle is the product of the length and the width. Okay, we know this. Area of a rectangle, okay, is no more than length times width. So in this case, to be able to get our algebra tiles, our x squared tiles is the product of length of x and width of x. So we have an area of x squared. Our x tile is a product of length of x, just like our x squared tile, and the width of 1. 1 times x will give us x. And our unit tile, or our 1 tile, is a product of length of 1, width of 1, which gives us an area of 1. Okay? We can use algebra tiles to model more complex rectangles. These rectangles will help you understand how to find the product of simple polynomials. The width and length each represent a polynomial being multiplied. Okay? The area of the rectangle represents their product. So what does that mean? Let's take a look at what that whole thing means. Okay? So let's consider this example. Let's say you have x times x plus 2. You don't have to work with a partner. You can work with anybody at home if you wish. Okay? You want to make a rectangle with a width of x. Okay? And the length of x plus 2. So this is our rectangle. Okay, this is our unfinished rectangle. We have a rectangle with a width of x and the length of x plus 2. 1 plus 1 equals 2. Use algebra tiles to mark off the dimensions on the product mat. If you notice, if you multiply x times x times x will have an area of x squared. So we'll get our x squared tile and put it right there. Okay? And if we have x times 1, x times 1 will give us an x tile. So we'll get an x tile and put it there. Okay? Another one, x times 1 again is x. That'll give us an x tile. Bring it there. Okay? And that forms our rectangle. Okay? So this is our rectangle right over here. Oops, not straight. There. Okay? Nope, that's a circle. Okay? So our rectangle is right there, Okay? There you go. So that is our rectangle. And if you notice, okay, if you look at a rectangle, what is the area of a rectangle? There's one x squared tile, and there are two x tiles. Okay? So, in this case, the area of a rectangle now is area of a rectangle will be 1x squared tile and 2x tiles. So it is x squared plus 2x. Okay? So if you notice, if you multiply x times x plus 2, it'll be x squared plus 2x using our model. Okay? Before we learn the concept, let's talk about this particular example. Chain link fence is going to be installed around the school tennis courts. To determine how much fencing is needed, a representative from the fencing company measures the length and the width of the region that has to be enclosed. Total length of the fencing can be determined by finding the perimeter of the rectangular region. And we know that the formula for perimeter is equal to length plus the width plus the length plus the width, or simply 2L plus 2W. Okay, simpler than that, we have perimeter is equal to 2 times the quantity L plus W. So in the expression 2 times L plus W, a polynomial is being multiplied by a monomial. Okay. This is our monomial, 2 is our monomial, and L plus W is our polynomial. Again, definition of polynomial is the sum of monomials where L and W are both monomials. Okay? So in general, the distributive property can be used to multiply a monomial and a polynomial. Okay, how did that happen? Okay, if you look at this carefully, let me erase the red marks right here. Okay, if you look at this carefully, if I get 2 and multiply it with L, and I get 2 and multiply it with W, I end up with 2L plus W. And that's using the distributive property. Okay, in this case, they went the other way around. 2L plus 2W is the same as 2 times L plus W. Okay, so we use the distributive property to multiply a monomial and a polynomial. How does that help us? Okay, let's find out. Okay, as you saw in 14.5a, wherein we used algebra tiles to get the product of a monomial and a polynomial. You can use algebra tiles to multiply a polynomial and a monomial. The figure at the right is a rectangle whose length is x plus 3, right here. Why is it x plus 3? Let me tell you why. Because, okay, the length of this x squared tile is x. The width of this x tile is 1, 1, and 1. And that's why it's x plus 3. X plus 1 plus 1 plus 1 is x plus 3. Okay? And the width is 2x. Why is it 2x? Because the length of this x squared tile is x. And the length of this x squared tile is x. X times x, or sorry, x plus x is 2x. That's how you got 2x. Okay? So how do you use this to be able to multiply polynomials? The area of any rectangle is the product of its length and its width. We know that. The area of this rectangle can be also found by using by adding the areas of the tiles. If you notice, if we multiply 2x times 3x and we get the area of this whole rectangle, what do we have? We have, okay, using that formula, okay, we have, no, not that one, this one. Using algebra tiles, I mean. Okay, let me go back, and then there you go. Oops. There, disappears again. Using algebra tiles, okay, we have, if you want to find the area of this rectangle, there are 2x squared tiles and 6x tiles. So, if we add them all up, the x squared plus the x squared, these two, and all the x tiles will give us 2x squared plus 6x. That is the area of this particular rectangle when the width is 2x and the length is x plus 3. And that's using algebra tiles. Okay? Using the formula, area equals length times width, we have x plus 3 multiplied by 2x. Again, we discussed that we can use the distributive property to find the product of a monomial and a polynomial. So we simply distribute the 2 to x and 2x to 3. So if we multiply 2x times x, end up with 2x squared. If we multiply 2x times 3, we end up with 6x. So it's the same answer right here and right there. So in this case, we use algebra tiles. Okay, in this case, we simply use the formula using the distributive property. The distributive property can be very useful, probably more useful than algebra tiles, because when the numbers become bigger, it is going to be very difficult for us to draw algebra tiles. Okay, so this method is the one that we are going to use more than anything else. Okay, the formula method. Let's see. Let's take a look at this example and see. Let's see what I mean. Let's say we want to find each product. Okay, Let me extend this page, I have more space. We want to find the product of 7 times 2x plus 5. To be able to do that, again, we use the distributive property. We distribute 7 times 2x, okay? So this becomes 7 times 2x. And then we distribute 7 to 5 plus 7 times 5. Okay? So simplifying what we have there, 7 times 2x will give us 14x. Okay, 7 plus 5 is 35. The product of 7 times 2x plus 5 will be 14x plus 35. Okay, let's move on to example B. We have 3x minus 7. We multiply that by 4x. So we simply distribute our 4x. So we now have 4x times 3x. And then we distribute 4x to negative 7 minus 4x times 7. Okay? So 4x times 3x will give us 12x squared. And 4x times 7 will give us 28x. And this is the simplest form of this polynomial, simply because there are no more like terms. Okay? And last example, we have 2ab multiplied by the polynomial or the trinomial, negative 9a squared plus 5ab minus 4b squared. Okay? Let's use a manly color here. Let's use a nice green. Okay? So we get our 2ab and we multiply it with negative 9a squared. So we have 2ab and multiply it by negative 9a squared. Get your 2ab multiplied by 5ab. And finally 2ab, okay, minus 2ab. Oopsie, it won't fit. Let's move this baby. Wait, just this one. Okay, this the one fit. Okay, never mind. I'll erase it and then we'll redo this over again. Okay, and then we'll write it better. So you have 2ab okay, multiplied by negative 9a squared plus 2ab multiplied by 5ab and then minus 2ab multiplied by 4b squared. Close that. There you go. Okay. Okay, and we simplify all of them. 2ab times negative 9ab from what we learned in terms of our rules of multiplication. Okay, powers of exponents. Okay, powers of products. You have now negative 18a cubed b plus 2 times 5 is 10. A times a is a squared, and b times b is b squared, minus negative 2 times 4 is negative 8. A times a does not have a common base, so we simply write a. B times b squared is b cubed, and that is now the product of 2ab times the quantity negative 9a squared plus 5ab minus b 4b squared. Okay, and let's take a look at this example. Example number 2. Sometimes problems can be solved by simplifying polynomial expressions. Okay, let's take a look at this one. The world's largest swimming pool is the Ortli Pool in Casablanca in Morocco. It is 30 meters longer than 6 times its width. If the perimeter of the pool is 1,110 meters, what are the dimensions of the pool? So we are asked to find the dimensions of the pool, and it is said that the length is 30 meters longer than 6 times its width. So we need to create a let statement. Okay, like what we learned in every word problem, there's always a let statement. You know the perimeter of the pool. We want to find the dimensions of the pool. Okay, this is the perimeter of the pool, 1,110 meters. The dimensions of the pool. When you say dimensions, what do they mean? The dimensions are basically the length and the width of the pool. Okay, that's what they're trying to find out. So let's plan how to do this. Yeah, again, our let statement. If W represents the width of the pool, then 6W plus 30 represents the length. Where did 6W plus 30 come from? 6W plus 30 came from this sentence. It is 30 meters longer than 6 times its width. 30 meters longer is plus 30. 6 times its width is 6W. Okay? So W represents the width. 6W plus 30 represents the length. Then let's write our equation. And it is assumed in this problem that we know the formula for perimeter of a rectangle, because the pool is obviously a rectangle. Okay, so the formula is P equals 2 times the quantity L plus W. So this is now the perimeter formula for a rectangle. Okay, solve this. We know that perimeter is equal to 1,110. We know that the length is 6W plus 30, and we know that the width is W. Okay, from our let statement. 6W plus 30 is our length, W is our width. We simply substituted the values for L and W. From there, okay, we continue on. We start simplifying, okay. 1,110 equals 2 times 7W plus 30. Where did 7W plus 30 come from? Remember from our last lesson, okay, previous lessons, that we have like terms 6W and W. When we add them up, you end up with, okay, 7W. And this is where it came from, right there. Okay? So that's where 7W came from, and we simply brought down the 30 right there. We simply brought that down. So we now have 1,110 equals 2 times 7W plus 30. Again, we use the distributive property. We distribute 2 to 7W, distribute 2 to 30. We end up with, okay, oh, not that one yet, this one. We end up with 1,110 equals 14W plus 60. And then, what do we do next? We subtract 60 to both sides. Why did we subtract 60 to both sides? Because we want to solve for the variable W. And in order to solve for the variable W, the objective is to isolate W. And the first thing we need to do is undo 60. And in order to undo 60, we need to subtract 60 from each side. And this is from commandment number 8 of our 10 commandments of math. Whatever you do to one side of the equation, you need to do to the other side. Okay, moving on. So, from there, we want to solve for W. In order to isolate W, since 14W is multiplication, we employ inverse operation. So we divide both sides by 14, which undoes 14 on this side. Okay, and 1,150. How did 1,050 came about? We subtracted 60. Okay, so we divide that, end up with W equals 75. The width of the pool now is 75. But we're not done because it's asking for us to find the dimensions. We only found one dimension, which is the width. We need to find the other dimension, which is the length. So we simply go back to our let statement, okay, and substitute 75 to W in the our let statement. Our length is 6W plus 30. So if we get 75, okay, and substitute it to, sorry, let me make that straight. There you go. If substituted to W, that's what we get. Okay, 480 meters. Okay, so that is now uh, the solution to our problem. Okay, we now have. See if I can erase this. Oh, I can't. Okay, we now have the dimensions of the pool, which are 480 meters as the length of the pool and 75 meters as the width. That's a huge pool. Okay, and if we want to check our answer, see if it's correct or not, if the width is 75 meters and the length should be 30 meters longer than 6 times 75, it would be 480 meters. It checks out. At the same time, the perimeter is 2 times 75 plus 480, which gives us 1,110 meters, okay, which is also the area of the ortholy pool. Okay, the solution checks out, and our answer is correct. Okay, and that's the end of our lesson. So in your notebook, uh, write the summary and type it on Google Forms. Actually, you don't need to write it in your notebook anymore. Just enter it on Google Forms and then write a question you might want to ask in class about this lesson. Okay? Thank you.